In this session, we will talk about the attached biological treatment, which involves this trickling filter process and rotating biological contractor. Biological treatment is mainly carried out for removal of organic carbon material in the wastewater and to remove nutrients such as nitrogen and phosphorus from the wastewater. The second main purpose is to treat the sludge, that is, treat the waste activated sludge for disposal. In the aerobic biological treatment, the water from the primary treatment, that is from the primary sedimentation, enters into the secondary treatment, which is also called as the biological treatment. The biological treatment can be performed in two ways. One is the attached growth process and the other process is the suspended growth process. In the suspended growth process, the microorganisms are suspended in the wastewater to be treated. That is, the microorganisms are freely floating in the wastewater and acting upon the carbon material. Whereas in the attached growth process, you have a media where the bacteria is attached to. So the wastewater flows through this media, and as it flows through, it is acted upon by the microorganisms which are attached on the surface of this media. In the aerobic biological treatment, the most preferred method of attached process is the trickling filters. So trickling filter is one of the attached biological treatment process which is widely used for treating industrial waste and also for municipal sewage wastewater. The widely used suspended growth process is the activated sludge process, which is used to treat waste water from industries and from sewage water, municipal sewage water. So both these attached process and the suspended process are aerobic process which encourages growth of aerobic bacteria, and so these aerobic bacteria which grow in the treated water acts upon the organic material present in it, and finally what is expected is reduced level of BOD, nitrogen and ammonia in the effluent. In today's class, we will talk in detail about the attached biological process, where we will talk in detail about the trickling filters and the rotating biological contractor. As the wastewater flows through the medium, microorganisms get attached to the surface of the medium and form a film which is called as the biofilm. The microorganisms attach on the surface and start acting on the organic material in the wastewater. As they start feeding on the wastewater, organic material in the wastewater, the biofilm gets thickened. As it gets thickening, as the thickening increases, the layer inside towards the surface of the medium, the oxygen is getting depleted. The oxygen cannot penetrate through the thickened layer. So the microbial growth on the surface becomes depleted with oxygen. So growth of anaerobes is encouraged. And the top layer of the slime layer interacts with the organic material in the sewage water, and there is enough amount of oxygen, so aerobic growth is encouraged on the outer layer of the slime layer. The slime layer is usually 0.1 to 0.2 millimeter thick, and as the slime layer gets increased, the thickness gets increased. The outer layer, that is the aerobic layer, cannot get attached to the attachment to the surface is getting loosened, and so the time period this gets starts to detach. So the microorganisms on the surface lose the ability to get attached and they are washed off in the flow. This process is called as slowing. Yes, L, O, G, H, I, N, G, slowing. So the detachment of the microorganisms on the surface is called as the slowing process. The slowed out microorganism is picked up in the under drain system. It is removed through clarifier for the removal from the wastewater. This microbial layer, that is the biofilm, consisting of the anaerobic layer and the aerobic layer together, it is called as the zooglial film. It is also called as the zooglial film. The first type of attached biological process is the trickling filters. So this trickling filter is a fixed bed. So there is a layer of this bed material. It is fixed. It is not moving. So it is fixed bed biological reactor. These trickling filters, they are also called the trickling biofilter, biological filter, and biological trickling filters. These biological trickling filters operate in the aerobic condition. So here, if you see the model, the wastewater from the primary treatment, from the primary sedimentation tank, enters into the trickling filter through the inlet pipe, and it moves to the what is that? Distribution rods, and it is sprinkled on the surface of the bed media. So the wastewater is sprinkled on top of this bed media, and this sprinkled wastewater flows through this bed, and it enters and it is filtered through the bed media, and the water that trickles through the bed is flowed out in the bottom of the tank. You have the outlet at the bottom of the tank, which is collected and sent to the second clarifier. The aeration in the fixed bed is by natural process. So this tank is open to the atmosphere. So the airflow is natural through the media. Since the wastewater is trickled or sprayed over on the top of the tank, it is called as trickling filters. As the wastewater filters there through this bed, it is called as the trickling filter process. If you see in the trickling filter, the main components of the trickling filter are the retaining, the tank where the process is carried out, the retaining system, the media, that is the filter media which is packed inside the tank, the distribution system which distributes the wastewater on the filter media, and the under drain, that is the filtered outlet media which is obtained outlet, no, effluent is collected by the under drain system. So these are the main components of the trickling filters. One is the retaining system, media, distribution system, and the under drain system. The retaining system, what are they made of? So if you see here, they are concrete. These tanks are made up of concrete material, and usually they are cylindrical in shape. Some also have it in square shape, but mostly what we find is cylindrical tanks. And the height of the tank usually is 4 feet, and there are also sewage treatment plants which use 50 feet height retaining systems for the treatment. The media, the second component in the trickling filter, is the material which provides the surface for the bacterial growth. So these media provide a large surface area for the biofilm formation. The organisms are able to grow on the surface of the media to form a thin biofilm. So they oxidize the organic material in the wastewater. They oxidize it into carbon and carbon dioxide and water. And also new cells, bacterial cells are formed, which is called as this new biomass. So the biofilm is formed on the surface of the material, that is the media, and usually these uh, the biomass is formed on the bed media is called as the slime layer, which is usually zero point 0.1 to zero point 0.2 millimeter thickness. When we talk about the media, what is the material we use here? There are different materials which are used as media materials. Earlier, rocks or slags were used as the media in the trickling filters. Nowadays, synthetic materials are being used as the media in the trickling filters. So here they are broadly classified into two types, that is stacked or random filling media. So these stones, slags are of this random media material, and the synthetic material can be of stacked or of random type. So here which can be ideal filter material is that first of all they should be of low cost, they should be durable in nature, have a high surface to volume ratio, they should be of light weight and provide proper air circulation. The synthetic material is which is being currently used in the treatment plants, sewage treatment plants. So usually they are that is PVC media or polypropylene media is being used to make this media. They are structured media material, and why this is used is because they can be easily stacked one above the other. So they can be easily stacked one above the other. They provide easy maintenance, less maintenance cost, and it is giving more efficient process of the BOD treatment. And another important thing is less odor produced by these materials. The synthetic material which is being used, they can be of structured type or of random materials. The structured type, so they have if you take the structured type, they can be of cross flow pattern or vertical flow pattern. And here the difference can be in the channel size. The channel can be of a smaller channels or of a bigger channels. Smaller channels give more surface area for the biofilm formation. Bigger channels, they don't give large surface, but the thing is less clogging will take place here. So less clogging risk in using bigger channels. The problem with the smaller channels is they have clogging risks. The random or dumped packing material, synthetic material, they are used mostly in the aquatic treatment plants than in the sewage treatment plants. Here it can be used for any type of tanks, that is whether it is a circular or whether it is a small shaped or a big shape. It is just randomly packed here, just like your rocks and the slags. But the problem is they are having less mechanical strength, and cleaning maintenance is difficult with this random dumped packing. So they are not usually used in the sewage treatment plant, but only in the aquatic systems they are used. Here we were talking about the structured materials. So they have what is it, cross flow or vertical flow. Cross flow is the one which is used mostly in the wastewater treatment plants, that is in the trickling filters. Trickling filters use the cross flow pattern material because they give good air water mixing, whereas the vertical flow pattern is used only when a particular flow pattern is required. And bubbles, aerated bubbles create, aerators are used to create bubbles, and here they are usually used in submerged fixed bed reactors. The third important component in the trickling filters are the rotating distribution system. These rotating distribution systems help in spreading the wastewater uniformly on the filter media, whether it is a rock filter media or a plastic media. So it is helped to distribute the wastewater uniformly. What is this rotating distribution system made of is, it has a hollow central column, and from the central column two or more radial pipes of some centimeter long is attached to the hollow vertical central column. And these radial pipes usually are rotatory arms. This rotatory arm is used because uniform hydraulic load of the wastewater will be distributed, which will increase the efficiency of the treatment process. So usually 2 to 4 arms are attached to the vertical column, but there are also, vertical column, and you can see here this distribution pipes helps to uniformly spread the wastewater on the filter media. Usually 2 to 4 pipes are there from the vertical column, but there are some treatment units which use many arms attached to the vertical column. So the rod has splash plates which is helping for uniform distribution of the medium. Trickling filter works on the aerobic biological process. So here proper aeration is essential for efficient functioning of the trickling filter. So here large ventilations at the bottom of the tank and enough void space in the media is uh, gives a proper aeration in the trickling filter. So air, that is oxygen, it is provided by two ways in the trickling filter. One is by the oxygen is drawn in by the vacuum effect by the ventilations. As the trickling filter is prickling, due to the vacuum effect, the air is pulled from the ventilations. That is called as the chimney effect. And the second is the oxygen is supplied to the trickling filter due to the temperature differences. Temperature difference in the sewage water and the surrounding. If the temperature in the sewage is low compared to that of the temperature in the surrounding, then air is sucked into the trickling filters. Vice versa happens when the temperature outside is low and the temperature in the sewage is high. The oxygen is pulled out of the system. So due to the so overall, if you see, the aeration in the trickling filter is by passive diffusion. Due to this aeration and the sprinkling of the wastewater, the movement of the wastewater in the media and the flow of air gives a proper water-air mixing in the trickling filter. Based on the hydraulic and organic loading rates, trickling filters can be classified into standard rate filters, high rate filters, and roughing filters. Standard rate filters, the hydraulic loading rate is between 25 to 100 gallons per day per square foot. The organic loading rate is between 5 to 25 pounds of loading per day per 1000 cubic feet. And the media what is usually used in standard rate filters is rock media, and it is around 6 to 8 feet in depth. Here through the standard rate filters up to 50 to 70% BOD reduction is obtained. The second type of filters, trickling filters, are the high rate filters. Here both rock and synthetic media are used as the media material. The hydraulic load in rock media is 100 to 1000 gallons per day per square feet. For synthetic media, the hydraulic load is between 350 to 2100 gallons per day per square feet. And the organic loading for rock media is between 25 to 100 pounds of BOD per day per 1000 cubic feet. For the synthetic media, the organic loading rate is 500 to 300 pounds of BOD per day per 1000 cubic feet. And I told you both the media, that is rock and synthetic media, are used. So the rock media here is usually 3 to 5 feet tall in the tank, and the synthetic media is around 15 to 30 feet is packed in the tank. From the high rate filters, around 65 to 95% of BOD reduction is obtained, and here it can be also used for nitrification process. The third type is the roughing filters. So roughing filters are capable of handling high organic loading rates of 100 to 300 pounds of BOD per day per 1000 cubic feet. Here it is used to reduce the organic load by oxidation process. And roughing filters can be used as a pre-treatment for treating high strength wastewater. So the wastewater from this enters into another biological treatment. So it can be used as a pre-treatment method process. So roughing filters are used in applications where the discharge system is not very stringent. So that is, I told you, it is a pre-treat, can be used as a pre-treatment. So here discharge is not very stringent. So it is used as a pre-treatment for high strength industrial waste that is discharged into sanitary sewer system for further treatment. Advantages of a trickling filter. One is low energy requirement, as the trickling filters do not require any additional energy consuming equipment such as air blowers. The energy requirement is low. The second advantage here, the sludge and the solids from the trickling filter are primarily composed of the slowed off biological slime layer. So these tend to settle and dewater easily than from waste activated sludge. So waste sludge is easy to dewater in the trickling filter process. And low maintenance requirements is only required for the trickling filter. Since there are very limited number of moving parts, there is very low maintenance of the equipments. equipments. Consistent effluent quality, that is trickling filters perform extremely reliable at low and consistent loadings. So trickling filter technology is a simple and reliable process. Resistant to toxins and shock loads, the trickling filters have the ability to handle and recover from shock loads since they are not very complex mix systems. And easy operation of trickling filters is possible because they do not require a high level sophisticated operation here. The problems or disadvantages with trickling filter: excessive organic loading or inadequate ventilation can lead to anaerobic decomposition, which causes objectionable odors, smells. And here, filter flies, and other insects can flourish well around the trickling filters. So they can be a problem in the trickling filter system. And potential for clogged media: excessive slogging of the media slime layer can cause portions of the media to become clogged. Weather can cause freezing. Icing of the distributor arm, orifices or spray nozzles is a common problem during winter months. And the fourth one is lack of adjustment, where trickling filters do not have features which allow them to be quickly adjusted for rapid increase in loading. In addition, trickling filters cannot be fine-tuned to achieve a high level of treatment. Pumping costs. It may be necessary to pump the wastewater to a higher elevation so the flow can go out through the distributor. Additionally, recirculation of wastewater may be necessary to achieve sufficient wetting of the medium. Rotating biological contactor is also one method of attached biological treatment process. So it's also called as rotating biological filters. It is a fixed bed reactor. And here the process is similar to the trickling filter, as the bacteria, the microorganisms form a film on the surface of the medium, and this biofilm acts on the organic molecules in the wastewater. So the process is similar. But what is the difference is, here the microorganisms on the media come in contact with the wastewater by rotating the media in the wastewater. So it is by rotating the media in the wastewater, the biofilm interacts with the organic molecules present in the wastewater. But in the trickling filter, we had the media bed on which the wastewater was sprinkled. So here, but in the case of rotating biological contactor, the media is rotated, submerged, and it is rotated through the wastewater, during which the microorganisms interact with the organic molecules in the wastewater. That is why it is called as rotating biological contactor. Rotating biological contactors have a series of circular, light-weighted rotating discs, usually which is 2.5 millimeter diameter. They are mounted, so this gives a specific surface area for the biomass to grow. And the circular discs are mounted on a horizontal rotating shaft. So here we have, so you have one media pack. This is one media pack. So around 2 to 3 media packs are mounted on a horizontal rotating shaft. The discs, the plastic discs, are usually made of high density plastic sheets are used here, which are of PVC, polyethylene or polystyrene make. And usually this rotating biological contactors are placed in a covered environment to protect the biological process and also to avoid damage by ultraviolet radiations. If you see here, the media, around 35 to 45% of the media is submerged in the wastewater tank. So the components of the rotating biological contactor are the horizontal shaft on which the plastic, high density plastic sheets which are closely packed are mounted on the shafts, and the shaft is rotating, so it has a motor which helps in rotating the shaft. So this is immersed in the shaft with the plastic disc is immersed in a tank which is carrying the wastewater to be treated. So if you see here, this shaft is rotating at a very slow speed of 1 to 2 rpm. So we have a tank which is filled with the wastewater on which the shaft is placed, and the shaft is packed with the closely packed plastic sheets, that is the carriers. And here the bacteria, so around 35 to 40% of the media is immersed in the wastewater. So when it is in the wastewater, it is going to act on the BOD, and the bacteria will be making use of the BOD as the nutrient, and it will grow. I told you this rotating biological contactor is a aerobic process. So where is the aeration provided? So if you see here, part of it is submerged, but as it rotates, the submerged portion is exposed to the air. So when it is exposed to the air, it gets oxygen for the metabolic process. So when it is unsubmerged, during the rotation, when it is unsubmerged, it takes oxygen from the air for the metabolic process. And when the disc enters into the wastewater, it acts on the BOD, uses it as a nutrient for its growth. So as a result, the biofilm will be formed on the surface of the media. So as the film grows, the top layer will not be able to attach, so it will die and fall off the media surface. So this dead bacteria and other solids are removed in the secondary clarifier. So media what is used is usually 12 feet in diameter, and the shafts, the horizontal shafts are usually 25 feet long. Media areas up to 1,80,000 square feet per shaft is used. The overall flow diagram for the RBCs, so there is an influent, the wastewater, where primary treatment is undergone, where the large particles and the solids are removed. Then from the primary clarifier, it enters into the secondary treatment. So rotating biological contactor is a type of aerobic process, and the method is an attached biological process method. So here you can have this biological series of biological reactors. So from that is the treated effluent, it enters into the secondary clarifier for further treatment. The benefits of the RBC systems: it is easy to install, very low maintenance, and it is operator friendly. This is a simple biological process, can be defined for BOD, and ammonia removal for nitrification is done. So both BOD reduction and nitrogen reduction is also done with RBC systems. So it is